Hi everyone, I hope this message finds you well and that you enjoyed your 4th of July. So the video you're about to watch deals with Chapter 9, Conducting Experiments. Now a few things. First, a lot of knowledge in this chapter assumes that you really grasp the concepts from Chapter 8 and a lot of stuff from Chapter 7, Chapter 4, and Chapter 2 as well. And then second, I'm also making the assumption that you have the PowerPoint in front of you so you can follow along as we go. So let's dive into it. But before we actually present new material, I want to kind of go over some stuff that's really important for this chapter itself. And this generally deals with just how we prepare for an experiment. And this involves 4 separate things. Now first, this deals with how we operationally define our variables, which is a lot of stuff we went over in Chapter 2. Our sampling technique, which is something we just covered in Chapter 7. Are we using a probability or non-probability? Designing a measurement procedure. Now this deals with a lot of stuff we went over in Chapter 5 related to, construct validity and reliabilities of our measures. And then lastly, designing the actual experiment really relates to a lot of stuff in Chapter 8, the types of designs, dealing with their independent and dependent variable. So the first thing we need to prepare for when conducting an experiment is our operational definitions of our variables. Now here, we should be operationally defining our independent variable, as well as operationally defining our dependent variable. Further, if we can, we should try to operationalize any constructs that may influence our relationships, whether it be a cause and effect relationship, or just a relationship between 2 variables. So for instance, if I want to measure IQ, can I actually operationalize a measurement or in such a way that I can actually tap IQ? And this really deals with using a theory to drive our operational definitions. Now remember, regardless of what a theory actually is, regardless of if it's useful, regardless of if it's falsifiable, the most important thing is that it's theory-driven. Thus, when trying to make an operationalization of a variable, we should really be looking at a theory that has a lot of data to support it, and that this theory itself, that has data to support it, can really drive our operational definitions. So in this case, when measuring IQ, I would really have to look at past research, how the research that supports the idea of IQ operationalizes the construct itself. Now once we have an operational definition of our variables, both their independent and dependent, we need to figure out how we're actually going to get our participants. Now here, we really need to first ask, are we going to use a probability or non-probability sampling? So for the most part, we would think that probability sampling is a better method. However, we really need to ask ourselves, is it always a better method? And the way to really determine this is if you need your sample to be representative of your population. Now there are often times when you just need to do a quick experiment and don't need to generalize it. You just need a quick answer to a question. Doesn't matter if it can generalize to everyone, you just need an answer. However, for the most part, we do want to generalize our data, and this presents a problem as often we don't have a full list of our population, and thus we can't accurately implement probability sampling. However, there are often times where it's not necessarily a negative thing, and your experiment just doesn't give a hoot about whether it does or does not contain probability sampling. For instance, if you're examining something very fundamental in regards to what it means to be a human, and this often relates to a person's physiology, how their brain functions, their heart rate, their skin conductance, all that stuff doesn't vary that much across genders, ethnicities, cultures, or even ages. Maybe ages a little bit, but for the most part, the physiology is very consistent among people. So in this sense, if your study is really looking at something that fundamental, that physiological, it doesn't matter if you have probability sampling, because you're not really it's the different characteristics of the sample itself won't be influencing the physiology. As well, if your dependent variable under investigation is unrelated to any participant variables in your sample, it doesn't matter if you do or do not use probability sampling. So for instance, if you do not think that your dependent variable is related to a person's age, to their gender, to their race, maybe even to the religious background or the political affiliation. If you don't think your dependent variable is related to any of these participant variables, then it doesn't necessarily matter if you do or do not use probability sampling. And the reason for this is it doesn't matter what your participants differ in their characteristics, because it's not going to influence your study. It doesn't matter what age, race, or gender they are, because this is not influencing the actual variables in your study. So if this is the case, in which you're actually conducting a study that's not influenced by participant variables, then you don't need to worry about probability sampling. Now that you've defined your variables and have a sample, you need to figure out how you're going to use or actually implement your measurement procedure. And this deals with a lot of stuff we went over in Chapter 5. So we have to ask ourselves, are our actual measures in tapping measuring the construct under investigation? And this really deals with construct validity. And we can really answer this, by doing a face validity test, which is the worst kind, or being a bit more stringent and maybe doing a discriminant or a convergent validity type of test. And then further, if we're able to establish our construct, validity and be measuring that construct, is our measurable reliable? Will it measure it the next time, maybe with the same participants, maybe with different participants? Not only do we want it to be valid and actually tap that construct, but we want it to be reliable and tapping the construct itself. And this goes for both independent variables in successfully manipulating a construct and dependent variables in successfully measuring a construct. And the last consideration before we actually dive into conducting the experiment is how we are actually designing it. And this deals with a lot of stuff we went over in Chapter 8. So when really deciding what kind of design you want to use, whether it's a between subjects or within subjects, you need to ask yourselves, are you seeing changes within a person or changes between people? And more so, this is between different people. So if you're using a between subjects design, comparing two different groups with two different groups of people, you're really comparing different groups and not, changes within an individual, how the same individual responds in different situations. You're more so considered in how just people in general respond to a situation. But within subjects designs, you're investigating the same people under different situations. So you expose a person to a stimulus, measure their response. Expose them to another stimulus, and measure their response. So here, you're investigating the same people, changes within a person. And then lastly, the mixed subjects design, it's kind of a bit of both. For the most part, we've really thought of it through the idea of counterbalancing, order 1 of a within subjects design, order 2, the orders being the between subjects variable, the actual conditions in which participants are exposed to as the within subjects variable. However, it can often be too that you can get creative and have both a within subjects design, or within subjects and between subjects variables that are manipulated. But that's a bit more than this class hopes to address. But what this class does hope to address is, which design is best going to help you answer your research question. And this even goes for the experiment you're conducting. When deciding whether to use the between or within subjects designs, if you are using an experiment, you need to select the one that's going to best help you answer your question. And then remember, when designing an experiment, your independent variable is independent because it is independent of influence in the design. It is doing the influence on the participant's variable, on the participant's dependent variable. And here it is the dependent variable as it is dependent because it is contingent on the influence in the design. So I hope you really understand, why the independent variable is independent of the design, it's doing the influence on the design, in which the dependent variable is in, being influenced. So now that we know, the four main things we need to prepare for, we can actually go into conducting an experiment. Now, because experiments generally involve two main things, a manipulated independent variable and random assignment, we can really, for the most part, we understand random assignment, so we can really start differentiating on different types of manipulations. So the first kind is a straightforward manipulation, and this deals with a manipulated stimuli that is implemented either verbally, either visually, or with written instructions. So for instance, a study was conducted recently that looked at how morals influence environmental attitudes, with the general idea that for the most part, it is care attitudes about the environment that are related to pro-environmentalism. However, some authors suggested that it could also be some type of disgust, some type of violation of purity of the environment that can elicit pro-environmental attitudes. So what these researchers did is they exposed participants to different manipulations, or more so to different stimuli. So as we see on the left, we see a chopped down forest and cracked ground. These were the visual stimuli used for the care condition. Now for the disgust condition, the other type of moral under investigation, they use actually this nice Los Angeles picture right here of dirty air and then dirty drinking water. So here, to manipulate these conditions, they actually use a visual manipulation. Now, another type of straightforward manipulation is actually using verbal instructions. So for instance, a theory that's very popular within social psychology is known as terror management theory. And this theory states that when people think about their death and about their afterlife, they are more likely to cling to their world beliefs and are more likely to support their culture. Now, when investigating this theory, most researchers use this prime in a verbal sense, or specifically, they tell their participants to write down the feelings you think you would experience when you die. So participants are told this, and then they write down the feelings that they believe they would experience when they are dying. Now this is the treatment condition. As the control condition, they say, please write down the feelings you think you would experience when you're watching TV. So in that sense, we have a treatment condition of think about how you're going to feel when you're going to die, or the control condition, think about how you're going to feel when you're watching TV. So this is done verbally. Or if you wanted to, you could do this one written. Now for instance, besides the actual prime, which was the terror management example, it could be just the actual instructions you give to participants. So for instance, if you tell participants the goal of the experiment is to obtain team points, hence you should try to maximize team, not individual points. Now let's say this is treatment 1. Treatment 2, the goal of the experiment is to obtain individual points. Hence, you should try to maximize individual, not team points. So you would tell participants one of these. So participants would be in one room, let's say, and hear one set of instructions, and participants in another room would hear another set of instructions. This again would be a verbal type of straightforward manipulation. As well, some research that I recently conducted actually used written manipulations to actually manipulate the construct under investigation. And what we actually did is we manipulated 3 independent variables in these different scenarios. So for instance, if you look at the difference between these scenarios, while they are similar, the things that italicized are actually different. So first, in the top scenario, the name is Christopher. In the bottom scenario, the name is Christina, the name of the individual they're judging. As well, so the top one talks about how it has a high GPA, engages in a lot of extracurricular activities. But in the bottom one, it talks about how she has a low GPA and avoids extracurricular activities. As well, it talks about up top how he reads in the student lounge alone and spends time alone on the weekends. While on the bottom, it talks about how Christina Davis hangs out with her friends and looks forward to spending time with her family on the weekend. So here, we actually manipulated 3 independent variables within these scenarios. Now we had a total of 8 scenarios, and these are only 2 of them. But overall, these were the things that we manipulated in the scenarios. We manipulated gender, we manipulated competence, high or low, and we manipulated warmth, sociability, high or low. As well, you could also do it in another kind of visual way besides, just pictures themselves. And this one is actually a combination of a visual and written and verbal instructions. So this is actually known as the Stroop effect. So in this kind of instance, researchers give participants something, or give participants a set of words in their actual color. So red is in red, blue is in blue, purple is in purple. So they have participants read through these words and they record how long it takes them to get through it. Now this is the control condition. The treatment condition is the mismatch. So red is in blue, blue is in brown, purple is in yellow, green is in black, and so forth. So here, not only is there an actual visual manipulation, but it's actually, the instructions themselves, or actually, it would just be a visual manipulation itself. I do apologize. So it would be just a visual manipulation. And some other visual manipulations, perhaps some that you're familiar with if you read this article. How facial hair actually influences attractiveness. This is a straightforward manipulation, such that, participants were exposed to one of these, given a dependent variable. Exposed to the other face, given a dependent variable. But here it's straightforward and that's a visual manipulation. As well, some researchers have used the same image of one woman and really manipulated, the body, the BMI of her, the actual weight. So here they have an underweight, average weight, and overweight model. In here, they are all visual manipulations. Now the second kind of manipulation is a staged manipulation. Now here events in the experiment are actually staged in order to help manipulate the independent variable. Now the goals of these manipulations are to elicit a certain psychological state within the individual and to make it seem like a real-life experiment. So you really oftentimes are deceiving the participant when you're doing a staged manipulation. However, some instances exist where you actually don't need a confederate or there are some instances where you can actually use a staged manipulation without an actual person. So for instance, if I were to give you false feedback on a test you took, let's say. So let's say you took a 10-item IQ test, and I give you false feedback either way. You're exposed to either receive good feedback, you did a good job, or you're exposed to receive bad feedback, you did a bad job, you got the numbers incorrect. So you could do this with an entire test, or in this example given here, you could do it with individual responses. So you respond to your question and you get it correct or incorrect. However, it doesn't actually matter if you did get it correct or incorrect. It depends on the type of staged manipulation, whether you're exposed to the true or false feedback. As well, I mentioned earlier with staged manipulations that you try to stimulate a real-life situation. Now this may seem familiar from Chapter 6, when we talked about the clean versus dirty parking lots and manipulating independent variables in a systematic observation. Now here, it's staged because researchers purposely cleaned or purposely dirtied a situation. Now these weren't the actual conditions, but it is a visual in regards to how researchers staged a certain real-life event for participants to be exposed to. Now one thing I mentioned in passing is the idea of a confederate. Now a confederate in a staged manipulation is a person who appears to be another participant, but is in fact part of the experiment. And this is common in studies involving social interactions, and it is also very common in observation studies. So for instance, I had a student last year who actually had who actually went around trying to figure out under what conditions are people more likely to comply to the new rule on campus to no smoking. So these individuals or this researcher would go up to a participant and either smile and make eye contact, smile and not make eye contact, not smile and make eye contact, or not make eye contact and not smile while asking them to put out their cigarette. But here, this individual did not know that this person was in fact part of the experiment. So this both involved social interactions, and it was useful in this observational study. As well, one of the most common types of stage manipulations that you may have heard of is Ash's conformity experiment. Now I do suggest watching the link that just appeared at the bottom on your own time, but as a brief idea overall of what the experiment was, is there's only actual one participant tested at a time, and the idea was of whether being around people who give incorrect information can actually make those individuals conform and give the false information itself. So it was one of the first conformity experiments. So if we see in the bottom right corner, it says real participant. So everyone around them is a Confederate. Excuse me. So there's one participant and 6 Confederates, and on the far right we see the actual researcher. So here, the Confederates were asked, the line on the left, is it most similar to A, to B, or to C? So they were told it was a perception experiment, really trying to match these lines to its most similar counterpart. However, it was the Confederates who actually gave false information. So while we can obviously see that this line is most similar to C, participants gave the incorrect information. They would say that this line is most similar to A. Then the researcher would measure whether the participant did or did not give the incorrect information. Now I suggest watching this link because it's curious as to how people perform even after all these years, such that while this experiment was conducted in 1952 to really kind of give an idea of how people complied within World War II, Nazi Germany, it's still interesting how after almost 60 years people are still doing this. Now, regardless of whether you are or are not using a stage or manipulation and you're using a straightforward one, you really need to focus on the manipulation strength, such that the strength of the manipulation influences how big of a difference there is between the conditions. Now, the difference between the conditions oftentimes is when you're comparing the averages. So what's the average response between condition A and condition B, between treatment A and treatment B. And here, when we're talking about hypotheses, confirmation, and manipulation strength, when there's a larger difference between the conditions, you're more likely to confirm your hypotheses. And this is because often, for experimental designs, you're examining a group difference. So when there's a larger difference between these groups, that's often in line with your hypotheses. When you're making a theory-based hypothesis, you are specifying which direction you're expecting a difference. So when there's a larger difference in the hypothesized direction, it shows even stronger support of your hypotheses. Now, one thing to do to really check the effect of your manipulation is called post hoc power. Now, the idea of post hoc power is when you actually say, if I reject my null hypothesis, so I reject the idea that there's no difference between my conditions, you ask yourself, was it due to my manipulation? So if I found an effect, was it actually due to my manipulated independent variable? Was it due, so you're really asking yourself, is there an alternative explanation to this effect? So this idea of post hoc power, we're not going to go over the statistical formula of it, but overall it's a statistical test to really examine, Was the effect due to the independent variable? So when you're trying to ensure that you have a strong manipulation, you need to consider two actual things on top of, wanting for it to be strong. And the things are, first, is it ethical? Is this manipulation violating participants' big three? So when I say big three, that's beneficence, maximizing benefits, minimizing risks and costs, autonomy, free choice to be in the experiment, and justice, ensuring an equal distribution of risks and benefits. So here the reason it's important is because deception experiments are actually very effective. They're a very strong manipulation. However, as we went over in chapter 3, we often know that that's a way to actually violate participants' autonomy and their beneficence and perhaps even their justice. Now the second consideration, which is very important as well, deals with the realism of experiments. Now I want you to have in mind Milgram as we go through these next few ideas, such that the Milgram experiment was really how often participants were likely to shock, the Confederate. But while this study had really interesting effects, we really need to ask ourselves a few things about the manipulation in this study. And these deal with the mundane and experimental realism of a manipulation. So when I speak of mundane realism, it's the extent to which an experiment is something participants experience in real life. So for instance, what I mentioned earlier about one of my students going up and asking someone to put out a cigarette, that has pretty good mundane realism, because for the most part, smokers on campus probably are often asked to put out their cigarettes. So in that sense, the mundane realism, the extent to which an experiment is something participants are commonly exposed to, something in which they could believe can happen on a daily basis, was good in the study I mentioned. However, let's think back to Milgram for a second. How often do you people come across situations in which you are in a situation in which you have to shock another individual? If you are in these situations commonly, I'd probably really question, your life choices. But assuming that you're not, this really makes us question the mundane realism of the Milgram experiment, such that while participants engage in this behavior, it can't really be generalized in this situation, such that people are not in situations where they are needing to shock other individuals. However, it's a bit different when we think of experimental realism. Now, experimental realism deals with the extent to which an experiment actually involves the participant, enmeshes them in the experiment, and elicits the appropriate psychological states. Now, let's think of this in regards to Milgram. Were participants involved, invested into the experiment? And did they have the appropriate psychological state elicited, such that were they conforming to the researchers' demands to shock the Confederate? In that sense, very much yes. It has good experimental realism because participants enmesh themselves in the experiment. They began following every order given by the researcher, and thus the researcher appropriately elicited the desired psychological state. Now the trade-off, however, it's that these sometimes go against each other. If you have good mundane realism, the extent it's something participants are experiencing in real life, it may not be something that they're fully engaged in. Oftentimes because they don't even know they're a participant. If you have good mundane realism, you might be doing an observational approach, and in that sense you don't know how aware participants are. You're not really controlling for how they're going into the experiment. So there is a bit of a trade-off right there. So here is a check for this PowerPoint. I suggest pausing this video for 1 minute and trying to complete these. And what you're trying to figure out is whether this manipulation is a straightforward or a staged manipulation. So let's go through these. So number 1, participants were told to think about how they felt either certain or uncertain about their future. This is a straightforward manipulation. Let's say participants were given this verbally in instructions. This would be straightforward. As well, you could give this even written to participants to prime the desired psychological state. Number 2, a Confederate did or did not apologize after stepping on a participant's foot during an interaction. So it should be that first word, that second word that really gives you the kind of key idea of what this manipulation is, such that it is a staged manipulation. And this is because it involved a Confederate who was, part of the actual experiment. And then lastly, a Confederate either did or did not smile at a participant as they completed a self-worth scale. Again, the fact that it involves a Confederate makes it a staged manipulation. So now that we've gone over, manipulating variables, which really dealt with, the stage versus straightforward manipulations and the manipulation strength, we can dive into more focusing on our dependent variables. So here the first thing to figure out is whether we're using a direct measurement of our construct or an indirect measurement of our construct. So a direct measurement is when you directly observe and measure the construct under investigation. So for instance, if you're examining donating behavior, you would examine how much money people donate, how many clothes they donate, the exact idea of what you're defining as donating behavior. You say donating behavior is giving to a company. You see how much people give to a company or an organization. As well, recycling. Recycling itself is, if you define it as the behavior of, actually recycling cans, recycling plastic, recycling the plastic bottles, then in that sense, you can observe people engage in this behavior or not engaging in this behavior. It is a direct observation and measurement of this idea. As well, even something like self-esteem. Now this one, it actually deals with if you're asking participants, how they feel about themselves, how good they feel, how worthy they feel on an actual scale. And the reason this is direct is participants are directly responding to a question about their self-esteem. So in this sense, you're directly observing and participants are directly responding to a measurement of self-esteem. So this is why it is a direct measurement. Now the other one is an indirect measurement. The actual measurement you're using is tapping the construct in an indirect type of way. So going back to this idea of self-esteem, let's say you don't want to use a scale. You want to use, something more visual. So you say that self-esteem can be measured by how big a person smiles. So, if it's a frown or, no smile, that's not very much self-esteem. But if it's a big smile, a very, grandiose, great smile, then you would say, yes, that's high self-esteem. But this is an indirect measurement. You are using this theory to, operationalize an indirect way of tapping this construct. As well, you could also do this with an emotion such as anger. So you could ask participants, how angry do they feel on a 1 to 7 scale? 1, not very angry. 7, very angry. Or you could do this physiological. You could look at past research, see, how certain physiological reactions, increased heart rate, increased skin conductance, is related to this idea of anger. Now here, it's indirect because you're not actually measuring anger. You're measuring blood pressure. You're measuring skin conductance. However, you're just operationalizing anger through this actual measurement. So you're saying is measuring blood pressure is actually measuring anger at the same time. So as well with dependent variables, besides asking whether you are using a direct or indirect measurement, you really need to figure out whether it's one of 3 different types of dependent variables. In here, it deals with a self-report, a behavioral, or a physiological. So a self-report really deals with surveys and interviews. So if you ever come across, a Likert scale, an interval scale of measurement, it's going to be a self-report, and it's thus going to be a direct measurement. So anytime you come across a self-report survey or a self-report interview, it's a direct measurement of the construct. Now with behavioral and physiological though, it's different. With behavioral, it could be either direct or indirect. So it shouldn't say and, it should say or. So it could be direct or indirect. As well, the behavioral can be a variety of things. It could be a person's performance, it could be their actions, it could just be an assessment maybe on on a certain task itself. But here, you're measuring the actual behavior of an individual. So it could be a direct observation, you're interested in directly measuring the behavior you're observing, or you're defining some other construct through the behavior that you're actually measuring. So while self-reports are always direct measurements, behavioral is going to be direct or indirect. And then lastly, this goes the same with physiological. If you want to examine, how something increases someone's heart rate, how something increases someone's galvanic skin response, that would be a direct measurement. You're directly saying, this is going to influence their heart rate, their skin response, their blood pressure. However, if you use the approach I said earlier, where you're defining anger through blood pressure, through a heart rate, through a skin conductance, through an MRI, you're really using an indirect measurement, because you're just saying anger can be measured through this physiology. However, you're just measuring the physiology and not this direct idea of anger. However, regardless of whether you're using an indirect or direct measurement, regardless of whether you're using a self-report, a behavioral, or a physiological, you want to have converging evidence. Now, converging evidence is when you have multiple forms of evidence come together to support a hypothesis. And here, it's really overcoming a mono-operation bias. No, I'm sorry. It's really overcoming a mono-method bias, which was a construct threat a threat to construct validity in Chapter 5. So here, it's overcoming a mono-method bias. So here, the multiple measurements of a dependent variable are really just providing more support to your hypotheses. So for instance, if I were to ask you, define healthy eating, give me an operationalization for a dependent variable of healthy eating. So we could do this in a few different ways. So we could look at it through a self-report. I could ask people, how much, I could ask them in an interview, what do they eat and how often they eat it. I could ask them on a survey, their attitudes towards healthy foods. How much do you like fruit? Not very much, on a Likert scale. I could even use an Osgood semantic differential. I could put, let's say an apple as a stimulus and, get people's ratings of it, very appealing, not very appealing, disgusting, not very disgusting. So you could do things like that. You could also do behavioral. You could watch what people are eating at lunch, You could record this behavior every day for a month to measure healthy eating. As well, you could really do another one. You could say, healthy eating is when people do not eat McDonald's, so almost kind of a negative in that sense. So here, when people do eat McDonald's, it's an instance of unhealthy eating. Or as well, maybe you just want to take a physiological approach. And here, you look at blood work to get glucose level, to look at cholesterol, look at how many vitamins and minerals are in the system. As well, you could just do maybe a different type of physiological stuff. Look at their observation of their weight, their height, and their body fat, a BMI. So here, regardless of if you're doing a health eating survey, whether you're watching, a little cute child eat McDonald's or, green smoothies, or you're actually trying to see, what's the difference physiologically between a healthy status and a stress or disease. These can be all measurements of a dependent variable. However, when selecting a dependent variable, it is often important to note the sensitivity of it. Now, when I speak of sensitivity, it is how minute and specific you get with your actual measurements. So, for instance, let's say I wanted to measure healthy eating on an interval scale. So I decided to use a Likert scale format and to try to really tap healthy eating habits. So I ask people, how often do you eat an apple, let's say? 1, not very much. 3, very much. However, that's not very many response categories. That's 1, not very much. 2, maybe moderate sometimes. And then 3, very much. That's very broad categories in that sense for an interval scale. So you would want to get more sensitive, have more sensitivity in your measure. You would want to get more minute, more specific with your actual measurement. And this is where you might want to go to a 1 to 7 scale. With 1, not very much, 7, very much. 1, strongly disagree, 7, strongly agree. Here, you're giving more room, more response categories for participants to respond to. As well, this idea of sensitivity is really important to ensure that you don't run into 2 types of ruining effects for your data. Now, it really deals with the idea of scaling, but more so think of it more with sensitivity. Sensitivity is really necessary to overcome these 2 effects that deal with what kind of scale of measurement you use. And these are known as a floor effect and a ceiling effect. So with the floor effect, it is when all scores on a dependent variable are actually very low. And there can be some different reasons for this. It could be, let's say, it was a task you gave participants and it was too difficult for them to complete. It took too much time. Or it could be that, there was just a confusing wording of it. There was a disagreement among the definition, and participants all scored very low on this construct. So here, for a floor effect, its all scores are very low on the dependent variable. The opposite is a ceiling effect, when all scores are very high on a dependent variable. Now this could also be for a variety of reasons. Perhaps a task you gave someone was too easy. It was very simple and they could really, get through it quickly. As well, it could be the idea of acquiescence. If your statement is a loaded statement and is very positively worded, participants are more likely to agree with it. And that's just the phenomenon of acquiescence, is that people are more likely to agree with positively worded statements. And then as well, if there's just a lot of agreement on what you're actually asking participants, they may score really high. So for instance, if I were to ask you, how much do you look forward to your Fridays, a lot of people would probably raise their hand and we'd thus have a ceiling effect. We'd have a lot of high scores on this dependent variable. And then one last consideration for your dependent variable, if you get either a ceiling effect or a floor effect, is the sample representative of the research question you are asking? Sometimes, if you're using convenient sampling, you may not actually get a sample that's representative of the research question that you are asking. And here's a nice visual of floor and ceiling effects. Floor effects on the left-hand sides when everything's really low. Ceiling effects on the right-hand side when everything is really high. So now that we've gone over, measuring variables, which dealt with dependent variables, and manipulating variables, which goes over independent variables, let's really finish up and focus on some last issues that occur when conducting experiments. So one of these is pilot testing. And this is a small-scale experiment with a few participants. And this is often done to really perfect your manipulations. So here you really want to perfect your manipulations, really, work out any wording issues in your survey questions, and often receive feedback from some participants on just the design and the measurement procedure itself. And really here, the researcher should be open to new information. Oftentimes, a lot of researchers aren't open to changing their experiment too much, especially once all the materials are made. However, that's the whole point of a pilot test. You are really ensuring that your measurement, that your variables are doing what they're supposed to and can be understood appropriately by participants. Now another thing you could do is something called a manipulation check. Now this is a way to effectively see, is your manipulation effective at what it's supposed to be doing. Now here, it's actually a different way to check the manipulation's effectiveness in comparison to post hoc power. Specifically, post hoc power, after you get results, attempts to establish how effective was the manipulation. Here, with the manipulation check, it's directly examining, is the manipulation effective? So for instance, if I were in the example I gave earlier, in which I gave a description of two different people, Christina and Christopher Davis. As a manipulation check, I asked participants, what was the gender of the leader you were exposed to? And this was really to ensure that participants were aware that they read about either a male or female leader. Now with post hoc power, if I were to find a difference, I could go back and say, oh, there was this much of a chance that it was due to this effectiveness. However, with the manipulation check, I could directly show that my manipulation was effective and that participants were aware of that. And as well, if you have no significance, you could do a manipulation check. You can actually go and see, oh look, my manipulation didn't have an effect. It didn't manipulate this construct appropriately. Participants overlooked this manipulation, and that's why I didn't find any kind of effect. However, do note, with the manipulation check, it often leads participants to hypothesis guessing and makes the demand characteristics salient. So with the demand characteristics, as a reminder, this is when the hypothesis of the experiment becomes aware to the participants in the experiment. And if we think back to Chapter 5, this is a social threat to construct validity. So while this puts us at a paradox, while manipulation checks are more effective than post hoc power in determining the effectiveness of your manipulation, they actually present the problem that they potentially make the demand characteristics salient. However, there's a few things you can do to overcome the demand characteristics, and these are setting the stage, having filler tasks, or even using your best friend deception. So when I speak of setting the stage, this is when you're really kind of laying a cover story for the participant in the experiment. So you are actually being direct with what will happen and what they will actually do. So for instance, if you tell someone, they're going to read about an individual and then judge this person, you are being accurate in what they're going to be doing in the experiment. However, in setting the stage, in presenting a cover story, avoid explaining the purpose. You do not need to actually state the constructs under investigation. That is 100% the easiest way to give away the hypothesis of your study. So for instance, in the check I had earlier was something known as a self-uncertainty prime. I was asking people whether they were certain or uncertain about their life and their future. So here, I'm not going to tell participants you are being primed with self-uncertainty. I'm going to tell them you will think about aspects of your life and your future in this study. So here, I'm not lying to participants. They will think about aspects of their life and their future in the study, but I'm just not telling them what the actual construct is that I'm investigating and is thus related to my hypothesis. You could also use something known as a filler task. Now, a filler task helps obscure the relationship between a manipulation and a measure. So oftentimes, a filler task is in between the manipulated variable and the measurement of the dependent variable. However, your filler task should produce no effects, such that whatever task participants are exposed to in between the independent and dependent variable should not influence this cause and effect relationship. It should not be a confounding variable such that it should not obscure the hypothesized relationship between your cause and your effect. Overall, a filler task should just help set the stage. It should help the individual think they're in an actual experiment that they read about. However, do note that it is different from setting the stage itself. And then lastly, Deception, as I said, our good old friend, is an effective way to overcome demand characteristics such that when you're directly lying to a participant, they're probably not going to guess what your hypothesis is. However, this does make it an at-risk study. So, while deception, makes it an at-risk study, it does allow us to overcome these demand characteristics. So it is somewhat of a caveat that while, at-risk studies are not necessarily good because they often put participants at psychological risks, it is a very effective way of overcoming demand characteristics. So here's one more check. I suggest pausing it and completing this on your own before we proceed. Okay, so let's go over these three. So the first one, in a study about the effects of empathy on donating behavior, you tell them that they will be in a study that has them read about charities. This is setting the stage. Because the thing is, you're probably going to actually have them donate to this charity. So setting the stage is just kind of telling them, giving them an idea of the dependent variable they're actually going to be related to. But you're not actually mentioning empathy or how the relationship between them. Number 2, in a study comparing the effectiveness of sad and happy advertisements on well-being, you have participants complete 10 math problems before indicating their well-being. So this is a filler task. The math problems should be irrelevant to a person's well-being, and they should not influence the cause and effect relationship from the advertisements to the well-being. Lastly, in a study examining anxiety, you tell participants they are either going to get an extreme or mild shock during a memory experiment. This is a good old lie and is thus deception. You're not examining anxiety, you're examining anxiety, you are not examining memory. Now the last thing that we need to account for when conducting an experiment is experimenter expectancies. Now I've talked about this quite a bit already in this course, especially in Chapter 5 when we went over the social threats to construct validity. And here I call it reactivity on the researcher's behalf because it's the researchers influencing the measurements and designs because they want to confirm their experiment. They're reacting to the situation and trying to give away cues and make participants respond accordingly. However, there are 4 things we can actually do to overcome experimenter expectancies. And this can be a single blind, and these are a single blind study, a double blind study, or we could standardize the procedure or automate the procedure. So let's go over what these mean. So experimenter expectancies, the first thing we could do is a single blind study. Now in this situation, the participant does not know whether they are receiving an experimental or a control condition, but the experimenter does. So in this sense, you're really more removing you're not allowing for participants to engage in hypothesis guessing. You're kind of removing aspects that could give them cues. And here it overcomes experimenter expectancies because while the researcher does know what condition they're in, it makes it harder to give away cues of the actual experiment because the participant does not know what condition they are in. So for instance, if we expose participants to a happy or a sad video, participants do not know if they are in a happy or a sad video, but the researchers actually do. Now even further, being more meticulous is a double-blind study. So here, neither the participant nor the experimenter know whether the participant is receiving an experimental or the control condition. And here, this is something that you can actually do in Qualtrics, which I'll be going over when I return from the trip and start class again. And here, the participant doesn't know if they're receiving the treatment or the control condition, and the researcher neither knows whether the participant is in the treatment or control. And this is a very effective way of removing experimenter expectancies, such that if the experimenter does not know which condition they're in, they can't actually influence participants. So here, if participants, let's say, were in a happy or a sad condition and they didn't know, and neither did the researchers, we really are eliminating any type of experimenter expectancy. However, there are a few things you can actually do with the procedure to overcome experimenter expectancies. So here, the researcher actually trains people to carry out the procedure in the exact same way. So you give them pre-written scripts. You make sure that there are no extraneous behaviors and thus confounding variables in your study. So you do a lot of things, really control the environment, ensure both rooms are the same temperature, both rooms are the same lighting, same times of day. You really ensure the procedure is exactly the same in every way that you can. However, in standardizing the procedure, this is you teaching someone else to do it. You, the researcher, teaching someone else to do this for you. Now, with automating the procedure, it's a little bit different. So you're using pre-recorded instruction. You're using automated pre-timed slideshows. So here you often don't even need to be there to actually implement and conduct the experiment. You're using something that's pre-recorded to actually do it. As well, this is actually something we will be doing in Qualtrics itself, such that because it's an online survey, you don't need to be there. It's something that's already done, automated in the actual procedure itself. And then lastly, before we finish up, always, always, always remember to debrief your participants. The participants need an explanation of the purpose and the rationale behind the study. And here, you're really allowing to get feedback from your participants, and you're really kind of going to allow yourselves to, or allow them to recalibrate, kind of get their wits back together before going out of the experiment. But more importantly, you're really kind of minimizing any unforeseen negative reactions. You're decreasing and removing any type of psychological risk itself. So overall, when we conduct an experimental design, we're really using a lot of stuff that we've learned so far. So we have a defined population, and from that we have a certain type of sampling procedure. So we use a probability or non-probability, but we thus get a sample from our population. Then afterwards, we randomly assign them in this experiment to a treatment or a control. And here, while I have it as a treatment or a control, it could be a treatment 1 or a treatment 2. But here, what you're really asking is, are you using a staged or a straightforward manipulation? As well, afterwards, are you going to have any kind of filler task? Are you going to try to set the stage and throw participants off? Then as well, are you going to use a manipulation check? Are you just going to use post hoc power to check the effectiveness of your manipulation? Or are you actually going to have a manipulation check to test the effectiveness of your manipulation? And then lastly, with the dependent variable, are you going to use one measurement, really actually make yourself vulnerable to a monomethod bias? Or get converging evidence, overcome this monomethod bias, and use multiple dependent variables? And then afterwards, I always suggest looking at demographics to get a good idea of your sample, and then of course, debrief your participants. So this is the end of this lecture. If you have any questions related to this, please email me and let me know. As well, you will have a Lab 8 due next Wednesday by 12 p.m. And again, please let me know if you have any questions about this.